Delve into art, architecture, and design with Srijan Design Academy SDA and thrive in exams, college, and career. Welcome to SDA. Figure-based aptitude. Topic 17. Path length in 2D figure. Relevant for exams like NATA, JEE P2, CEED and UCEED.
Hello everyone. We are doing this exercise today that is called finding the path length in 2D figure. In most of the exams you will find this question where you will find circles, squares, triangles, hexagons, or a combination of it. You will be given a point A and a point B, that is start and end, and then a line will be given between that. You have to find the length of it. So first of all, we'll start with the circle and we understand. So before starting, all of us know what is the circumference of the circle. So that is nothing but 2 pi r. So, but in this case, we need to use the quarter of the circle. So what is Q? So Q is 2 pi r by 4, and that is therefore pi r by 2. Okay. For simplification, what I'll do, I'll make it pi, that is at 22 by 7, and r in this case is 21 by 2 divided by whole 2. Therefore, we get this becomes your 3, and here if we cancel, this becomes your 11. So therefore, we get a simple number that is 33 by 2. Now all of you need to remember this number because that will be very important in most of the questions. If you don't need to remember, we can again do it. So in this case, let's figure out how many quarters do we have. So if I divide this circle, okay, so you can find one quarter here, you can find second quarter here. Furthermore, if I divide it here, you can find third quarter here, you can find fourth quarter here, you can find fifth quarter here, you can find sixth quarter here, and you can find seventh quarter here. So when we have figured out all the quarters, what we need to do? We just need to multiply it with this quarter number. That is 33 by 2. So 7 getting multiplied with 33 by 2. And that is our final answer in this case. So all of you in the comments, give me what is the final answer. Let's move to the next question. Again, we have some radius and some quarters. So quarter we have already figured out in the last case. Your Q was equals to 33 by 2. Okay. That is from the previous case. This will be useful here as well. So let's count how many quarters we have. So we are getting 1, we are getting 2, we are getting 3, we are getting fourth one, and we are getting fifth one. How many radius are there? So if I look at radius, there is one radius, second radius, third radius, and fourth radius. What is r in this case? R is nothing but 21 by 2. Okay. So if I find the simple answer in this case, it is 5 multiplied with 33 by 2 plus 4 multiplied with 21 by 2. So all of you comment what is the final answer for this question. Now we are getting combinations of the square. So in square there are two things. One is the side. So side is equals to a, that is given, whereas the diagonal is equals to a into root 2. Okay. Similarly, if you get d by 2, somewhere you will get half of the diagonal. So that will be a root 2 by 2, and therefore it will become a by root 2. Okay, so if you remember all these three numbers, it will be easier to calculate. We're getting one side, second side, third side, fourth side, and fifth is our diagonal. So we are getting d1. Let me call it simply d1. So four sides, that is 4 into 8 plus one diagonal, that is a root 2. So 8 root 2. So therefore our final answer is 32 plus 8 root 2. Okay, done with this. Let's move to the next question. Again, I told you multiple things that you can combine the diagonal or you can combine the sides, whatsoever you like. We know all the formulas by now. So let's just count. We are getting d1. Okay. These two, if I combine, this will become d2. Okay. Because if you look, we complete it here, then this also becomes a diagonal. Whereas this is d3 by 2. That means it is third diagonal and half. Let's talk about sides. So this is side 1. Okay. This is side 2 and this is side 3. So we're getting 3 sides and 2.5 diagonals. So let's solve it. 3 times of 8 sides, 2 full diagonals. So 2 into 8 root 2. What was half the diagonal? 8 by root 2. Okay. So from here, what we get? 24 plus 16 root 2 plus, either we can call it 4 root 2 or we can call it 8 by root 2. So I think calling it 4 root 2 will be far easier. And therefore our final answer is 24 plus 20 root 2. Okay, all of you are clear about this question? Let's move to the next one. Now we are getting a triangle. So in triangle, what you need to understand, the sides are pretty much clear. The side will be just 8 in this case. But what will be the diagonal? Okay, we don't have a diagonal in a triangle. I hope you all catch this. We have a perpendicular. So how do we find the perpendicular? For that, we apply the Pythagoras theorem, and where the side is A and this is A by 2, all of you can apply the Pythagoras theorem, and therefore P, which is your perpendicular, will become A by 2 and root 3. So we're getting one perpendicular and we are getting second perpendicular. Let's see how many sides we are getting. So we are getting side 1, we are getting 2. I can call this 3 by 2, and I can also call this 3 by 2. This is fourth side, this is fifth side, and this is sixth side. So we are all in all, we are getting 6 sides. So 6 multiplied with 8 plus 2 perpendicular. So 2 multiplied with 8 by 2 into root 3. So 2 and 2 getting cancelled. We have 8 root 3 and we are getting 48. So 48 plus 8 root 3 is our final answer for this question. Up next, you all need to comment the answer for this question. It's not complicated. It's very easy. You just have one perpendicular. Rest all are just sides. So I'm waiting to see the comments and waiting to see the correct answers from all of you for this question. Let's move to the next one. Here we are getting this question. What we have a hexagon and then some triangles. So let's understand what a hexagon is. A hexagon is basically nothing but combinations of 6 triangles. So all these are equilateral triangles. So if this side is 8, this side will also be 8. This side will also be 8. This will also be 8. This is also 8. And this is also 8. Because all the triangles are equal here, as we can see. So how many sides we are getting? We are getting 5 sides. So 5 multiplied with 8, and this becomes 40. This is a very simple question, okay, but looks very complicated. Let's move to the next one. Again, here we are getting sides and some perpendiculars. So let's figure out how many perpendiculars are there. So we can see P1, we are getting P2 and P3. So we have 3 perpendiculars. So 3 multiplied with 8 by 2 root 3. Okay, let's talk about sides. So we're getting one side, second side, third side. Good enough so far? If I combine, this is 4 by 2, this is 4 by 2, so all in all 4th side, and this is 5 by 2. So 4 full sides, that is 4 into 8, plus 1 half side, so half into 8. So overall, we are getting 32 plus, so 32 plus 4 plus 12 root 3, and therefore our final answer in this case is 36 plus 12 root 3. Okay, let's move to the next question quickly. Now, this is a very complicated question. You have a square. On one side, it is forming a triangle from its side. On the other side, it is forming a triangle from its diagonal. Okay, so for this question, what do we have? Let's identify each and every element one by one. So this side becomes 8. Clear? Now, we know what is the diagonal of the square. So diagonal of the square, which is this one, becomes 8 root 2. Okay, so therefore this side becomes 8 root 2. Now if I combine length from here to here, this is what? 8 root 2. Okay, if I look at this perpendicular, what is this perpendicular? This will be 8 by 2 root 3. This is half the side, so this is 4. Okay, so we have resolved all the parts. So therefore, what will be our final answer in this case? Pretty easy. 8 by 2 root 3. So that is nothing but 4 root 3. Second part is just 4. Third part is 8 root 2. Fourth part is also 8 root 2. So 2 times of 8 root 2. So therefore, our total answer in this case is 4 root 3 plus 4 plus 16 root 2. See how easily we are done with a very complicated question. We just understand the basics of geometry and some common formulas. So in this topic, which is finding the length of parts in 2D figures, you need to understand some basic combinations like diagonal of the square, perpendicular of the triangle, circumference of the circle, and you just need to understand certain combinations. It will be very easy to solve these questions. First of all, you learn to solve these questions in terms of roots, and then in the next part, we'll learn to understand these questions in terms of absolute numbers. It is very useful in CEED examination.
For more questions, drop a comment on our video. Subscribe us to Thrive in Exams, College, and Career.